Alright, so I make footballs and I make 55% of them perfectly. On the other hand, 10% are too big, 12% are too small, 32% have laces that are messed up, 7% are too big but the laces are correct, and we want to know what percentage of footballs that I make are the right size but don't have good laces. So we're going to make a Venn diagram, but before we do that, let's translate some of this stuff into mathematical equations. And when we make our Venn diagram, we should be a little sneaky about how we make it, and that might make the problem easier for us. Okay, so I'm going to let B be the event of a football being too big, S be the event that it's too small, and L is poorly laced, or the laces are messed up. Okay, so when we draw the sets in this Venn diagram, we don't need to draw a usual three-set Venn diagram, because remember, if I make a football, it can't be both too big and too small at the same time. So I can draw the sets B and the sets S in a way that they don't overlap. Now, I could have balls that are poorly laced and too big. I could also have balls that are poorly laced and too small. So L should intersect both of these. So now we have our Venn diagram, and we drew it in kind of a sneaky way that will make this problem a little bit easier. Okay, so now that we have those events, we have our Venn diagram. Let's translate some of this into equations. So this says the probability of B is 0.1. The probability of S is 0.12. The probability of L is 0.32. And this one's a little tricky. The probability of, so they're too big, but their lacing is correct. So too big is B, and correct lacing is L complement, because L is poor lacing. And we know that's 0.07. And we also know that 55% of them are perfect. That means 55% of them are out here, because the ones in B or in L or in S, those have problems. So let's put a 0.55 out here, because those ones are perfect. And let's start filling in this Venn diagram. Okay, so here we won't necessarily work from the inside out. Let's just start filling in what we know. So we know, for example, that 7% are too big, but have the right lacing. So too big and have the right lacing, that's over here. Because if you're in L, then your lacing is messed up. If you're outside L, then your lacing is correct. And in B means too big. We also know that total 10% are too big. So this circle representing B has to add up to 0.1. So that means this must be 0.03. Okay, what else do we know? Well, we can't directly fill in any of these other numbers, so let's put in a symbol and go from there. So let's put in an X right here, because we don't know that. So then we know that S in total is 0.12. So this area is 0.12 minus X, because then if I add those together, I get 0.12. And then the area in the middle, how do we represent that? So we know that the probability of L is 0.32. So this entire circle is 0.32. So this area is 0.32 minus 0.03 minus X. In other words, it's 0.29 minus X. So now we filled in the entire Venn diagram, and let's go from there. We know all these numbers have to add up to 1. All right, so if I add them up, I get 0.55 plus 0.07 plus 0.03 plus 0.29 minus X plus 0.12 minus X, and all of that equals 1. All right, so we combine our like terms, and if I'm doing this properly, I get, let's see, 1.06 minus X is equal to 1, or in other words, X is equal to 0.06. So now we can fill in this Venn diagram with the numbers themselves. So X is 0.06. That means this area is 0.12 minus 0.06, which is also 0.06. And then this area in the middle is 0.29 minus 0.06, which is 0.23. Perfect. So now we can answer the question. The question is, what percentage of footballs are the correct size but are poorly laced? So that means if they're the right size, then they're not in B and they're not in S, but their lacing is poor, so that means they're in L. So that's this 0.23 right here. So the probability of correct size means you're not in B and you're not in S, but you are in L, and that's what we're looking for. That's 0.23. The question wanted a percentage, so we just make that into a percent. So the answer is 23%.